Hello everyone. Today I'll demonstrate our script, which is a comprehensive example of how to perform a multiple linear regression analysis using the tidyverse, tidymodels, and dot-whisker packages. Below is a detailed step-by-step explanation of the script. Firstly, load required libraries. Tidyverse is a collection of R packages for data manipulation and visualization. Tidymodels is a framework for modeling and machine learning, providing tools for model fitting, evaluation, and tuning. Dot-whisker is a package for creating dot and whisker plots to visualize regression results. If you haven't installed it, please use the install.packages function, and inside of the parentheses, use the double quotes and put the function, the package name in. Because I have already installed it, so I'll just skip that. Load and inspect the data. The cars dataset is loaded from a CSV file using read CSV function. The data is converted to a table, a modern version of a data frame for easier manipulation. The cars dataset is displayed to inspect its structure and contents. Here is the first several lines of the cars. Set seed. Ensure that your result could be reproduced by fixing the random number generating seed. You can change one to any numbers you like. Initial split function, it splits the dataset into training 75% and testing 25% set. Training and testing, they extract the training and testing dataset respectively. And then we need to examine the correlations. Cars correlation, select if numeric, selects only numeric columns from the training dataset. The function of core computes the correlation matrix for the numeric columns. Round 3, that means we just keep 3 decimals. Sort function, it sorts the correlation values of the price column to identify the strongest predictors. We can see that the results are the correlations from the weakest to the strongest. Then visualize the relationships. We use ggplot to visualize the relationships between the price and other variables. First one is the price and the engine size. Multiple scatter plots are created using ggplot2 to visualize the relationship between price and other numerical variables like engine size, curb weight, horsepower, and so on. We can tell the relationship between them. So let's take an example of the car width and the price. We can see as the car width increases, the price increases as well. They have the positive correlation and the correlation is strong. And then we define functions for outlier detection. Get upper fence and get lower fence. Those functions calculate the upper and lower fences for identifying outliers using the 1.5 IQR rule. Values above the upper fence or below the lower fence are considered outliers. Then we can remove outliers. filter add function, it filters rows where all specified numerical values, wheelbase, car length, and so on, are within their respective fences. The outliers are removed from the training data to improve model robustness. Fit a multiple linear regression model. Linear reg, it specifies a linear regression model, and fit function, it fits the model using the training data and the specified formula. This is our formula. We try to predict price based on 7 independent variables. Those are the 7 independent variables inside our formula. And this is our data set. We are using training data set to train our model. Inspect model terms. Tidy model, it extracts the coefficients, standard errors, p-values, and other statistics for each term in the model. Then add predictions and residuals to test data. Here. Predict generates predictions for the test data using the fitted model. Mutate adds columns for predictions and residuals. Actual price minus predicted price to the test data, which is the residuals here. And then we can visualize the residuals by using ggplot. A scatter plot of residual versus predictions is created to check for patterns. Ideally, residuals should be randomly scattered around the red horizontal line, y equals to 0. You shouldn't find any pattern inside of this plot. Calculate R-squares. R-square function computes the R-squared value to measure the proportion of variance in price explained by the model. So the bigger of the R-squares, the better. Check for insignificant variables. Tidy model, it filters the model terms to identify variables with p-values bigger than 0.05, indicating they're not statistically significant. Those independent variables are not significant. Then create a dot and whisker plot. DW plot, it visualizes the regression coefficients and their confidence intervals. A blue vertical here at x equals to 0 helps assess whether coefficients are significantly different from 0. Here's how to interpret the significance of each variable. The horizontal red lines represent the 95 confidence interval for the coefficient. If the interval does not cross 0, the variable is considered statistically significant, which resonates with what we saw from this step. Then evaluate the refitted model. Predictions and residuals are calculated for the new model by dropping statistically insignificant variables. R-squared is computed to evaluate the model's performance. Residuals are visualized to check for patterns. Our new R-squared and new residual plots. This script demonstrates a complete workflow for firstly data preparation, include loading, splitting, and cleaning. Second, exploratory data analysis, which is correlation analysis and visualization between each pair of variables. Third, model fitting and evaluation, which is multiple linear regression in this example. Fourth, model refinement. Removing insignificant variables, we can refit the model and check the residuals and R-squares using the new model. Fifth, visualization and interpretation of the results. So by running that, we can see that the model, the price can be predicted by using the curb weight, engine size, and horsepower. The use of tidy models and tidyverse makes the code modular, readable, and reproducible.